Hey class, this week we are finally going to dig into C++. We are going to go over some of the basic syntax and formatting, as well as some details into the difference between procedural programming and compiled programming, and then touch a little bit about object-oriented programming. So the first thing that I want to talk about is the difference between interpreted code and compiled code. You may hear these terms thrown out. Um, when you program, depending on what the language is, you may be either programming in an interpreted language or a compiled language. Now, the first thing that I need to get straight with you guys is there is technically no such thing as an interpreted language or a compiled language. That is, you can have a compiler or an interpreter for really any language, but 90% of the time, certain languages are known to be interpreted or compiled. So I will be referring to it as interpreted language or compiled language in the future, but just know that technically any language can be either of those things. Now, what I mean by that is all code must be converted from the English language that we understand to computer readable code, a machine language, right? It usually gets converted into binary and then assembly and then to binary eventually. An interpreter versus a compiler is about how it goes about that, right? So a compiled code is it takes the entire program and converts it to machine code all at once, whereas an interpreter will take it line by line. So if you look at this slide here, if you look on the compiled side, notice that there are some languages that are considered compiled languages, meaning 99% of the time, if you're coding in C or C++, Go, Fortran, Pascal, you are going to be using a compiler. In contrast, 99% of the time, if you're using Python, PHP, Ruby, JavaScript, you're going to be using an interpreter. Okay? With compiled code, you have your language. It's the code that you're writing in your terminal, and then it compiles it all at once to machine code, and then it's ready to run. Whereas with interpreted code, you write your language, it runs one line of it by using an interpreter, a virtual machine interpreter, and converts that to machine code, and then it does that with the next line. An analogy that I like to use is, let's say that you want to learn Japanese, right? The compiler method would be to let's say you're reading a book in English and you have a friend that's converting it to Japanese for you to teach you. The compiled version would be you would read the entire page in English, and then your friend would write that down in Japanese or say it back to you in Japanese. The interpreted version would be you would say a line, and then your friend would say the line in Japanese back to you, right? So it's taken one huge chunk is the compiled version, or line by line is the interpreted version. So why use an interpreted language? It's usually faster development speeds, and it's usually easier to understand. And the reason why it's easier to understand is because the language normally has been abstracted out, right? It is more of a higher level language. For example, Python, which is an interpreted language, was built off of C++, right? So C++ is a lower level language, meaning it's closer to machine code. Python was built on top of that. So it looks more like English, and you may have noticed that in your programming. Python is a little bit easier to read than C++. So yeah, usually it's higher level, easier to understand, faster development speeds. And I think the biggest reason is it is highly portable. What that means is as long as someone else has an interpreter, you can take that .py file, assuming it's Python, You can take that file and you can email that to your friend. They can just execute it and run it right then and there. As you may have noticed with C++, that is far more difficult because we have to make sure we all have the same compiler. If you don't have the same compiler, we need something like CMake that can kind of handle it. So it's way easier and way more portable for an interpreted language. Now, the downside to an interpreted language is that it is usually less secure and it is usually slow, very, very slow. And the reason why is because you're taking a line, interpreting the line, taking the next line, interpreting the line. And it's less secure, kind of for the same reason why it's portable. If anyone gets a hold of your file, they've got the source code. Whereas with something like C++, you can convert that to machine code, and you just have to send that machine code to someone. They have no access to the source code, but they still have all the parts they need to run that program. So, why compiled language? More secure, which I just touched on. More efficient. And the reason why it's more efficient is because it's usually a lower level language. It's closer to the machine. And so it gives you more customization. As we'll learn this semester, you can allocate memory yourself or deallocate it, or you can create pointers. I know this may sound like gibberish to you, but you have way more customization to handle the exact amount of memory that you need, which once again makes it better performance. Now, it's a double-edged sword because if you don't know what you're doing, you could create something called a memory leak, which is when you forget to deallocate your memory, which can cause performance issues. It's more complicated, harder to learn. So it's one of those things with, with the more control that you have over your program, the more knowledge that you need to have. So compiled languages, which is what C++ is and what we're learning, are really powerful, really relevant, sometimes a little unintuitive. So it's going to be a little bit of a learning curve. Now, the next thing is high-level versus low-level languages, which I've already mentioned. This is technically different than compiled and interpreted, yet there is a correlation there. Usually compiled languages are more low-level, where interpreted are more high-level. Now, all that means is how close to machine code are you? How close to the processor are you? So the lower the level, the more abstract the coding gets, the more unintuitive, the closer to machine language it is, but the more control you have. And then as you start abstracting away from the machine and start getting to higher level languages, it's starting to look more like human readable English, but you are getting further away, which means you're losing more and more customization. So an example would be JavaScript or Python, or something that you would use to maybe build a website. These things are higher level languages. They were usually built upon the backs of a lower language, but for all the reasons I've already mentioned, it makes them less secure, usually a little bit slower and less customization. However, they're quicker to develop, easier to read, right? And I'm not bagging on high versus low. Really, they're all different tools, and depending on what you're doing, whatever tool you have may be appropriate. You just need to understand the difference between these things. Funny enough, C++, and there's still some arguments about this, at a time, C++ was considered a high-level language because before it came C, and before that came assembly, right? And then, binary code, right? Fortran. So there was a time not that long ago that C++ was a high-level language, but now we have so many modern languages that are even higher than C++. C++ is starting to look more and more like a mid-level language at least, but more likely a low-level language. So there's a little bit of debate there. You may come across someone with different opinions on that, but you can't deny that there are many languages nowadays that are at a higher level than C++. Yeah, and we already covered that. Okay, so examples of high-level languages. This is Python, Java, JavaScript, and Ruby. Um, Java, funnily enough, is kind of a hybrid between compiled and interpreted languages. Um, I'll let you guys research that a little bit. It's kind of interesting. There are such thing as kind of a hybrid between interpreted and compiled languages. Low-level languages, C, C++, assembly, Fortran, right? Okay, the next thing I want to talk about is procedural programming versus object-oriented programming. So starting with procedural programming, that is older than object-oriented programming. What it is it's a series of steps. So you're kind of going line by line through a program. Now, you can hit something called a subroutine that will maybe take you out of that flow. Think of it kind of like a function, executes that, and then goes back. But really, at the end of the day, it's all line by line procedural. So you'll be going line by line through your main program. You may break off into a procedure, but then you'll always end up back into the main until you hit the next procedure. My day job, we have done a huge software conversion. So we actually have gone away from this. But when I was first hired, I was required to learn a language called Unibasic. Unibasic is a certain flavor of BASIC, which is the big language that was the rave in the 80s, right? Pretty much all your favorite arcade games were in BASIC. And it was funny because it was very much line by line, break off into a subroutine, go back into the main. And it's simple to follow at first, but then it can easily turn into spaghetti code, and actually it turns into something that's rather hard to follow once you get into a program that's like 10,000 lines of code. And a little bit of a tangent, my first project at this job was I had to get into their main program. This program is where all of our salespeople would make orders for our customers. And when they'd make a sales order, it would print a ticket for the customer. Somewhere in this program that literally was 10,000 plus lines of code, I had to add a message about the ticket, depending on what item they bought, and that needed to be printed on the ticket. I literally had to add one line of code, but I had to look through these 10,000 lines to figure out where to put it, and it was fun. It was really difficult to go through this, but that's what procedural programming is. It's line by line. Now contrast that to object-oriented programming. This is a somewhat new concept. It's not a language. It's a paradigm. It's a way we think about programming. It's a way we think about solving our problems. So instead of breaking the program up into little steps or subroutines, you think about objects. You think about blueprints, and you think about what kind of structure can I build that can be repeated, that can be called multiple times. And what you do is when you think of these objects, you think about what characteristics they would have. How would they interact? How would they behave? A little bit difficult to explain, so I will give you an example. An object. An object can be anything. So this is Bob. He is 30 years old, and he is a sanitation engineer. Okay? Bob, in this example, is the object, right? The attributes would be his name, his age, his occupation. You could even give him little functions of things he does, right? Bob walks, right? That could be a little function you write. But these are all things that describe Bob. Now, Bob is just an example of an object. He's more of a person, right? A person object. I could make another person and name him Joe, and Joe would have his own name, his own age, and his own occupation. So do you understand that an object is kind of the blueprint, the shell, and you can instantiate as many objects as you want, and they will all share the same attributes. They will have different values, but they will all have a name, they all have an age, and they'll all have an occupation, right? So a class is that blueprint which creates the object. So if this is Bob, the class would be the person. Bob would be a member of that class. Once again, I could make a new object named Joe that is still of the person class, right? Then I could make Frank, Susan, Lisa, whatever. I can make as many objects as I want, and they will all be of the person class. They would all be part of this blueprint. That's what object-oriented programming is. We are not going to jump into really coding this for a few weeks, but it is good to start thinking about how we would solve these problems using that style of programming. So, what does this mean in code? This is a little bit of C++ code for you. I don't know how well you can see it. Let's see if I can zoom in a little. Hopefully that works for you. I'll go through some of this upper stuff in the next few slides, but for now, I want to talk about the class. This is a person class, right? And within the person class, this is where I would define some of the attributes of that class. So we have a name, and that's of type string. We have an age, that's an integer, and then we have an occupation, that's also a string. So every time you call someone an object of the person class, they will have these attributes that you will need to assign values to. A constructor, I won't get into it too in depth, but a constructor is something that is initialized every time you call that object. So every time we call an object, a person object, we can pass in the name, age, and occupation. So if I passed in a person object named Bob, in the parameters, just like a function, I could put their name, their age, and their occupation, all within the parameter list, just like a function. I wouldn't get too hung up on this right now. We'll get into more of those details later. And then, as I mentioned, in addition to having attributes, you can also actually have methods, is what they're called, or functions. Something that object does, right? This is what the object has. This is what the object does. In this case, this object, or this method, is called display info, and all it does is displays the values of its attributes. Okay? So if you come down here, I'm calling my person class, and the object is Bob. So Bob is part of the class. Now these are the parameters from that constructor I told you. You would just pass in values just as you would with a function, and this would be the name, so this is Bob, this would be his age, 30, and this would be his occupation, sanitation engineer. So I have now assigned values to those attributes, all within the Bob object. Now, I can call the Bob method, right, to display that. So if I do bob.displayInfo, you'll see that the results, the results would be right here, right? So I threw a lot of jargon at you. Don't stress if you didn't follow all of it. I just wanted to give you a little bit of a taste of what C++ code looks like, especially when we start to utilize classes and objects. Okay? So spend some time looking at this, but you don't need to understand it perfectly right now. Okay. Now, this is why C++ is so tricky. This right here is the object-oriented way in C++ to display something really simple. I just want to display the name, age, and occupation of a person, right? It's 32 lines of code. This right here is the same thing in Python. Now, this is not object-oriented here. This is just a function. But look how simple this is. I just make a function called displayPerson. These are the parameters. And then I just print them. And then I call the function right here. I mean, it is so much simpler in Python. And that's what makes teaching this class a little bit tricky. It's one of those things where it's like, take my word for it, right? I promise you that when you are in your careers and doing more complex code, and even in your future classes at Weber State, when you are doing maybe data structures, object-oriented programming is so much more beneficial, but it takes more work on the front end, right? It seems silly for an example like this, for you to write all this code just to give you a little result. But I promise you, if you get in the habit now, there will come a day when you're doing really complex code and you'll be very, very grateful that it's organized in this structure. So hang in there, learn it, and I promise it'll benefit you later on. Okay, so now let's take a couple steps back, take a deep breath, and let's look at the basics of a C++ program. So we're not talking about objects and classes anymore. We're just talking about the simple syntax of C++. Okay, this is a very, very, very simple program. All you're doing, essentially, is printing hello world to the console. The first thing we want to look at are these little include statements up here. These are called preprocessor directives. Basically, when you put this little pound sign, this little hashtag, you are signaling to your compiler that you want to process the following statement before the execution of the program. Basically, if you put this little pound sign and write include, and then write this next little bit, you are including a library. So it's very similar to Python when you would include libraries, right? Maybe it's the pandas or NumPy, or a myriad other of libraries. But basically, other developers have created programs, and then they have saved those programs into files that we can now access and call. So when you include the statement, you are now accessing a whole bunch of different functions that you can use, and things like that for your program. So these two are probably the two most important. We will use other ones. But these two you will almost always put on your program. You will for sure always put the IO stream in all of your programs. IO stream is input output stream. This is what allows you to write things to the console and what allows users to write things into programs. Okay, so this little cout statement would not be possible, would not be recognized if you did not include IO stream. So remember to always include that one. String is used all the time as well, maybe not quite as much as IOStream, but it is used a lot. And that is what allows you to write strings. It seems like a simple thing, but C, you didn't have strings. You had to get characters and put them together in an array in order to get a string. With this, you can write words. Groundbreaking stuff. So always include that. This next part, when you use using here, this is what allows you to grab certain namespaces, is what they're called. I'm not going to dig too much into it right now, but using namespace std, get your brains out of the gutter. It means standard. When you put using namespace standard here, you are now saying that whenever you use something like cout or cn, you don't have to put something called a scope resolution operator. So if you didn't have this line here, every time you would put C out, you would need to put STD colon colon C out. So for simplicity, we put using namespace STD so that we do not have to include that. Now, this is a controversial topic, and there may be people, I know there's people that disagree with this, maybe even some professors. And the reason why they disagree with putting this on here is because let's say you write a function and the function is called cout. Whenever you reference cout, now the program is, okay, are we talking about cout from the standard library, or are we talking about the cout that you made? And so you need to put that namespace resolution operator to specify exactly what you're talking about. Now, my rebuttal to that is, it is horrible practice to be naming your functions something that already exists within the program. Either way, I'm fine if you use it, fine if you don't. Just understand what it is. And for this class, since we're doing simpler programs, I will almost always include it. Okay. Yep. So this is just some more details on namespaces. It means standard library. And this is what I'm talking about, the resolution operator. You would have to put std colon colon before every function from the standard library. So right here, cout, without the namespace, you would have to write that. Okay. So now we've gone over the preprocessor directives and we've gone over the namespaces. Now we're going to talk about the main. So this is what we would call our driver function. It's of type integer. Don't ask me why. That's just what it is. Main doesn't take parameters. You'd put curly braces to start and then end the function. And then the other important thing is you always put return. Since this is returning an integer, since it's int here, we would return 0. And this is just what you always do for a main. 2 slashes indicate single line comments. If you want to do multi-line comments, you can actually do a slash and then an asterisk to start it, and then an asterisk and a slash to end it. But this is how you do a comment for a single line. And then right here is the multi-line. Okay, cout is a standard function that prints to the console. These two little less than symbols are called insertion operators. What that does is it concatenates the function from the data being passed. So in English, that means cout means we're printing to the console. What are we printing to the console? We have to put this to tell us, or to tell what we're going to put, and then we write our string. Okay. There are kind of 2 ways to end lines. You can put the /n inside the quotes to end the line, or you can write the insertion operator again, and then you would put endl, ENDL. And then we always put a semicolon at the end of every line. If you do not put a semicolon, it will be a syntax error. So it's a little bit more tedious than Python in that respect. You need to always put a semicolon to end the line that you're on. Okay, data types. We went over this a little bit last week, but I'm just going to go over once again the ones that we use the most. So int is integers, whole numbers, floats, 32-bit decimals, double, 64-bit decimals. Boolean is true or false. So true is 1, false is 0. And then char is a single character. Now, you also could use string, but string does come from that string. Lost my train of thought. Not the namespace. Kind of the library. Excuse me. That the string library that's in this include statement. That's where string comes from here. Okay, so here's a little example of a little simple program. When we declare our variables, we would put one is the data type that is going to be returned in that variable. Then we'd put the name of the variable, and then we put its value, right? So we have a variable that's named num. It's of type int, and it's assigned the value of 10. And then always remember your semicolon. When we want to print something to the console, we would do cout, the insertion operator, and then we would write just text, right? We'd write whatever our string is. And this is what I was talking about ending lines. If you put the insertion operator again and then put end L, this is one way you can end that line. If you do cout and then the variable name, you would print 10 to the console. This prints 10 and then ends the line. Now, this is a way that you can concatenate different things. So here I'm printing to the console, insertion operator. I'm writing the string text, insertion operator. I'm writing the variable, so it's going to display the number 10, and then I'm ending the line. So this would say text : 10. Okay, cin is the opposite of cout, except instead of printing to the console, the user is inputting something that will display on the console. Notice that these instead of less than symbols, it's now greater than symbols. This is called an extraction operator. It may take some practice to remember which way they go, but when you are putting user input, you're doing the greater than symbols. When you're printing to the console, you're doing the less than symbols. Right? So in this case, if I do cin and then the insertion operator, I would put num. And so the user would be prompted to input something. Whatever I input is what would be assigned to that variable. Okay? So in this example, if I put 25, then this next line would print text 25. Okay, constant values. Now, if you put const before the data type, then you're just saying that once this variable is declared, it can never change again. So this is a good example to do with maybe certain math variables. Pi, for example. Pi will always be 3.14159. This will never be anything different. So if you know the value will never change, it's good practice to put const before. We're saying this variable named pi is of type double, and it's constant. It can never change. Once we declare it to be this, it will always be this. Which means if in a later line of code, if I put pi equals 7, I will get a syntax error because I already declared pi as a constant, right? Okay. Some arithmetic operators, addition, subtraction, multiplication, division. You guys should all be familiar with those. Modulus is interesting. I think we've already covered this though. This returns the remainder, right? It doesn't return. It doesn't. It's not the quotient. Sorry, that's the word I'm looking for. It doesn't return the quotient. It returns the remainder between two numbers being divided. This stuff, however, may be new to you guys because I do not think Python has this. The plus plus just means an increment. So if I have a variable x and it's equal to 0, and then I do x plus plus, so something like that, I'm now saying add 1 to it. So now x is 1. If I do this, it would be, that's kind of hard to see with that, something like that. Now we're saying subtract 1 from it. Plus equals is cool. So it would look something like this. X plus equals 1. Basically what that means is x is equal to x plus 1. So it's shorthand. So if that makes sense. So if x is 5, and then I do x plus equals 1, that's like saying 5 equals, oh goodness, what is happening? 5 equals 5 plus 1, right? Which is 6. And then the subtract from is just the inverse of that, right? Okay, division types, I already went over modulus. Integer division, that just drops the decimal places, and then regular division. One thing to note is, and I think I already explained this, but C++ will always keep the highest precision. So if I do 7 divided by 10.25, the quotient of that will also have 2 decimal places. Okay, that's really important to remember. There's been lots of times where I've lost some precision because I've forgotten that. Okay, library functions. We already went over some of the different libraries. CMath is another really, really important one. This gives you a lot of different things that you may want, but the square root function is probably the most applicable right now. This SQRT, if you want to take the square root of a number, you need to include CMath. Right? So this line of code would not work if you did not include CMath. Okay, almost done. A couple more. Set width. Okay, this is from the library IO manip. So input-output manipulation. So if you want to use this function, you need to make sure you include this library. This is for formatting things. So if I see out to the console and I just put the LOL, it would put LOL. But since I set the width to 5, what it does is it counts 5 spaces. 1, 2, 3, 4, 5. And it fills in the number of characters going backwards, if that makes sense. So since LOL is 3 characters long, we're actually starting at the 3rd place. So 3, 4, 5. So this is really nice if you want to format some strings to kind of make them look nice. Notice that this function, you do cout, you do the extraction operator, and then you would put set width, and then in here you'd put how many characters you want to set it, and then you would put your string. Set precision is also from IOmanip, so keep that in mind. This is interesting. This is how many places do you want it. If you put set precision just as it is, it just puts 4 numbers. So 1, 2, 3, 4. So same thing as set W, you'd put it in the cout statement, and notice that it just prints the first 4 numbers that it sees. Okay. Now, if you put fixed first, now fixed means you're only looking at the precision after the decimal point. Okay? So if I want fixed, then set precision 4, I'm not doing 1, 2, 3, 4. I'm starting after the decimal place, and I'm doing 1, 2, 3, 4. Okay, really, really, really important. And another way you can do that, if I can get away with it here, maybe, possibly, is you can actually write, oh, that looks horrible. You can put cout fixed set precision for num and l. Okay, kind of hard to see, but you can kind of all put it, oh goodness, you can kind of put it all in one line like this if you want. Okay, that is all I have for C++ basics. I am pretty sure that is all you need to know for the homework this week. Please, please, please reach out if you have questions. I know that I gave you a fire hydrant of information. So if you, I'm better one-on-one. So if you need help, reach out. I can help you work through some of these things. Just let me know. Other than that, good luck with the assignment this week, and thank you.